Hi everybody, welcome back to Viral Integrals. So in today's video we're going to show that the factorial n factorial is hiding inside this integral from 0 to infinity. Now normally n factorial means 1 times 2 times 3 all the way up to n, but the point here is that the same number can come out of the area under x to the n times e to the negative x. So anyway, the usual Feynman technique move is to create a function with a parameter in it. We will call it f of a, and we will let f of a be the integral from 0 to infinity of e to the negative ax dx. The reason for putting the a in the exponent is that when we differentiate with respect to a, powers of x will start appearing. Before we differentiate anything, let's evaluate f of a the ordinary way. The antiderivative of e to the negative ax is 1 over a times e to the negative ax. At infinity, this goes to 0, and at 0, it gives negative 1 over a. So subtracting leaves us with f of a equals 1 over a. Now here is the actual differentiation under the integral sign step. We take the derivative with respect to a while the integral is still sitting there. Since x is the integration variable, a is the thing we are differentiating against. And the derivative of e to the negative ax is negative x times e to the negative ax. That's where the x comes from. So after one derivative, the integral side has a negative x inside it, and the easy side has the derivative of 1 over a, which is negative 1 over a squared. Both sides have that minus sign, so if we cancel it, we get the integral of x e to the negative ax equals 1 over a squared. If we do the same thing one more time, the pattern starts to show up. Differentiating again brings down another negative x on the integral side. So we get x squared e to the negative ax. On the easy side, differentiating negative 1 over a squared gives 2 over a cubed. Now after n derivatives, the integral side is f sub n of a, and inside the integral we have negative x raised to the n times e to the negative ax. You can think of that as n copies of the same negative x factor appearing from n differentiations. On the algebra side, we are just differentiating 1 over a over and over again. The signs alternate, the power of a in the denominator goes up by 1 each time, and the coefficients multiply into n factorial. So the nth derivative is negative 1 to the n times n factorial over a to the n plus 1. Now these two expressions are the same thing, because they're both fn of a. So when we set them equal, the integral side has a negative 1 to the n from negative x to the n, and the closed form side has the same negative 1 to the n, so those signs cancel out. At this point we have a more general formula. The integral from 0 to infinity of x to the n times e to the negative ax dx is equal to n factorial over a to the n plus 1. To get the version we want, just plug in a is equal to 1. Then the denominator becomes 1 and the integral is n factorial. And it's worth checking the first few cases so it doesn't feel like magic. If you integrated each of these using normal techniques, integration by parts, you would see that the pattern agrees. So the final result is that the integral from 0 to infinity of x to the n times e to the negative x dx is equal to n factorial. And the variable name does not matter. If we later write the same integral with u instead of x, it's the same formula. U to the n times e to the negative u integrates to n factorial always. Alright guys, I hope you enjoyed that, and we will see you next time.